Now, let's continue our next topic, that is inside this drafting and annotation tab. Let's go to parametric. Okay, let's go to parametric. So here in the parametric, we have lots of options. So all these options I am going to explain in this particular part. Okay, so let's get started. Let us create a rectangle. Okay, now can you tell me what are all the features of a rectangle? It's very simple, right? The angle between any two sides must be 90 degree. The side opposite to each other will be equal, means this side and this side will be equal, this side and this side will be equal. Okay, so first we have this auto constraint. First of all, what is the meaning of constraint? First, let us understand that constraint means we are restricting someone from doing something. That's the constraint. Okay, that's the constraint. For example, for example, suppose I want the length of this particular rectangle must remain fixed. I want this breadth of the rectangle must remain fixed. I want the position of the rectangle must remain fixed. I want this angle between the two sides must remain 90 degree only. I want the opposite sides of the rectangle must remain equal. So all this is possible using constraint. Means we are restricting AutoCAD from changing the length. We are restricting this side must be equal to this side. Okay, we are restricting AutoCAD that this side and this side must be equal. Sorry, 90 degree. The angle between these two sides must be 90 degree. So that's the thing. So let us go to first auto constraint. Go to auto constraint. Now it will ask select objects. So select this object and press enter. Once you press enter, you will see some constraints have been added. Hover your mouse. Hover your mouse. See what is written. Parallel. Hover your mouse here. Parallel means these two are parallel to each other. See, once I am hovering my mouse here, you can see that this side and this side is getting highlighted. If I hover my mouse here, hover my mouse here, this side and this side will show parallel to each other. They are parallel to each other. Understood? Now one more thing is here. See, once I highlight this, once I hover my mouse here, you can see this side and this side are parallel to each other. See how it is getting highlighted, how two sides are getting highlighted, two parallel sides. See, see, these are the two parallel sides which are getting highlighted. Now we have one more thing, horizontal. See, once I hover my mouse onto this symbol horizontal, that means this line will become horizontal. Understood? And also you can see that this side, this angle here must be perpendicular, means see the two side which are getting highlighted, that shorter side and longer side, both are perpendicular to each other. See, they are perpendicular to each other. If I hover the mouse here, see, they are perpendicular to each other, means this side and this side are perpendicular to each other. So that's the auto constraint. Means we are restricting this rectangle, means we are restricting. See, suppose if you try to change it, you won't be able to change this. Suppose if I draw another rectangle where no constraint is there, Okay. Now click on this drag handle and move it. You can see that the angle between the two sides will change. Okay. But here you can see that as I have applied parallel constraint, so you can see that it will maintain the property of a rectangle. You can see that it will always maintain the property of a rectangle. Can you see that? Yes, exactly. So that's the beauty of this constraint. Means these two sides will always remain parallel. These two side will always remain parallel, and also this side will always remain horizontal. Okay, horizontal, and this two side will be 90-degree to each other. So that's the auto constraint. I will use auto constraint in lots of examples. Suppose if I create a rectangle here in the circle and create one more circle, go to auto constraint, select these objects and press enter. Now you will see that some more new constraint has been added. Obviously this parallel to each other, they are parallel to each other. Okay, this side and this side parallel to each other, this side opposite sides are parallel to each other. Okay, this side is horizontal, and also a 90-degree constraint is there, perpendicular constraint, perpendicularity between this side and this side of the rectangle. But one more constraint is there. You can see that here. Once, suppose if I select this rectangle and if I move this, let me try to change the, one second, select this. So see, this side is changing, but if I try to change the width of the thing, see, it is not getting changed. It is not getting changed. Why? Because two circles are there, and if you try to change the size of the circle, automatically the width of the rectangle will change. Suppose if you try to change the width of the, suppose if you try to change the width of the rectangle, width means this one, breadth. This is the length of the rectangle, this is the breadth of the rectangle, so it is not getting changed. See, it is not getting changed. Only thing which we can change by dragging, that is the length. But if I try to change the radius of the circle, then you can see the radius of the circle increases, and also the breadth of the rectangle also changes. So this is how it works. So that's the constraint. Constraint means this circle, this circle is restricting the breadth change. If I try to change the breadth of the rectangle, okay, if I try to change the breadth of the rectangle, it will not change. Okay, yes, from the rectangle. But if I try to change the radius of the circle, then obviously the breadth of the rectangle will also change. I'm sorry. So this is how it works. See here. So that's the auto constraint. So auto constraint can be used in lots of places. We'll explain with some examples. Don't worry. Now, let us see one by one this geometric constraints here. These are the geometric constraints. Geometric constraint means perpendicularity, coincident, like that. So see, first is coincident. First is coincident. Can you see that? Yes, coincident. Let us draw two lines. Draw another line. So see, we have two type of line. These two lines are not connected and they are connected here. These two lines are connected here. Go to coincident, select this and this. I selected this point and this line and this line. Can you see? This was the first selection. This was the second selection. So the first selection will remain, the position of the first selection will remain there itself and the second will move. Okay. Yes. And they became coincident. Now, change, if you try to change the position of this line, this coincident constraint will always remain. You cannot remove their coincident constraint. You have to delete it. If you hover your mouse there and select it, if you hover your mouse and you can select this coincident constraint and you can delete that. From here also you can delete. Okay, which constraint you want to delete? Suppose, wait, directly like right click and delete it. You can delete like this. Now you will see that you can disconnect those two lines. Again, go to coincident. Okay, coincident constraint. Suppose this is the first line I select. So if I'm selecting this as my first line, okay, and this is the second line. So you can see that the second line will move and first line will remain in its original position. But you can see that the coincident constraint applied at the center. Why is it so? Let me explain. See, let us draw one more line. See, I have drawn two more lines. Go to coincident constraint. Coincident. Okay, so this is the first line. Suppose, see, once I hover my mouse, if I hover my mouse here, you can see the coincident constraint will remain here. If I hover my mouse here, it will be at the midpoint. If I hover my mouse here, so it will be at this end point. So suppose if I click on this and then I click here, so see that red circle will come here. So left click here. So you can see the second line will move. And where? How it is constrained? It is at the midpoint. So it totally depends where you are clicking it. It completely depends. Okay, now these two lines are already connected. They are already connected. So go to coincident constraint. This is the first. This is the second. So see how they have constrained. Do undo. Go to constraint. This is the first constraint. This is the first. This is the second. So like that, they connected. So if you try to separate them, it will not happen. If you try to separate them, it will not happen. See, obviously it will not happen. I hope this is clear. Now we have next constraint, collinear. Let's draw line. You know what collinear means, right? Yes. Collinear, first object, and this is the second object. Obviously, the second object will move and first object will remain fixed. Like that. See, they became collinear. So we have two lines here. See, we have two lines. See, selection cycling is on. Selection cycling. Okay. See, if the selection cycling is on from here, okay, if you don't found this, you have to find it from here. Make sure it is checked from here. So make sure selection cycling is on, and once you select this, there are clashing of two lines. So that's why, which line you want to select? This line. So that, see, that line will be selected. Okay. Draw two more lines. Now go to collinear. Select this and this. See, those two became collinear. Create a rectangle here. and create a line here. Select this. Suppose this is the first object, this is the second object. How they became collinear? So they will always remain collinear. See how they are getting changed? They must always remain collinear. That's the beauty. I hope you understood it. Let us draw a circle and a rectangle. Go to coincident constraint. Select this. Once I select this, center will get selected. And select this endpoint or this one. Anyone you can select. Suppose if I'm selecting this, so you can see that particular rectangle will come here. So before that, what we can do, go to auto constraint and make it auto constraint. Enter. Now go to coincident. This is the first object. This is the second object. See that particular, the midpoint of this particular side will coincident to the center of this particular circle. Okay. Now let's talk about some more thing. Rectangle. Let's draw a circle. Let's draw a polygon. 6 sides. Let's say this is the center. Okay, like this. So now we can do coincident. Go to coincident. Suppose if I am selecting this side's midpoint, you can see that red color dot, and this one. So see how it became like that. But this is not correct. Go to auto constraint it. Now go to coincident, select this first and then this one. So see how that side is coincident. That particular edge of that polygon is coincident with the midpoint of this side of the rectangle. Okay, so if you want to maintain the shape, if you want to maintain the shape of this particular polygon, you have to do the auto constraint first. That's what I did. I did the auto constraint of this hexagon and then coincident. Now let's create two circles. Go to concentric. Select this and this. Two circle will become concentric. This is the concentric. So suppose if I try to change the center of this smaller circle, the bigger circle center will also change. But if I try to change the radius, obviously this one and this one, the radius will be different, but their center will remain always same because this concentric geometric constraint has been applied here. Okay, now suppose if I draw two circles like this, and go to coincident, select this and select this. So see, they will become coincident. Yes. So what is the difference? Do we have any difference? Yes, we have. We do have a difference. So here they are concentric, and you can see this coincident. This coincident is acting as a concentric only. But this concentric geometric center can be applied on the circle or arc. But this coincident constraint can be applied to lines, to rectangles, to polylines, to polygons, whatever you want. I hope you are getting my point. Okay. See, this is a circle. Let's draw an arc. Okay, now go to concentric geometric constraint. Select the first object. This is the second object. Now you can see this second object moved to this. So they are concentric. This arc and circle are concentric. Now we have fix. Go to rectangle. Go to fix. Okay, this constraint and select this. Now you can see that if I try to move this point will never move. Let me try to explain again. Go to rectangle and go to fix. Okay, we have to select. If I select a point, suppose if I select this point right here, because it is asking select point. Suppose if I select any point, then you can see that select this. If I try to move it, okay, this will be moved, but that point will always remain fixed. You cannot move that particular point. That point will always retain its point position. Okay, see, like that. I hope you are getting my point. Now let's delete this. Now go to fix constraint again. Okay, now this time I will select object. Go to object, select this object. If I select this particular object, you can see that that particular object will no longer can be moved. Okay, however, you can increase or decrease the size of that particular object. Here the object was this particular line. However, you can increase or decrease the size of that particular object, but you cannot move it. Press undo. Okay, yes. Suppose if I select this, see, you can increase or decrease the size, but you cannot move the position. Go to object, and select this point. Again, go to object and select this particular line. Now you can see, because here I selected the point. Here point lock is there. So what we can do? Go to fix and then object, select this object. Now you cannot move this particular rectangle because all four sides are fixed now. Okay, exactly. So this is how object and point works. Now we have parallel constraint. Parallel, it's very simple. Create a line, create a polygon, 6 sides. Center of the polygon is this one, circumscribed about circle, and this. Okay, now create a rectangle as well. Now go to parallel, select this and this. Can you see that this side became parallel to this line? Do undo, parallel. Now I will select this is the first object, this is the second. So see, they become parallel. Okay, now go to parallel constraint again, parallel geometric constraint. Select this and this. See, those became parallel to each other. Suppose you want to remain its position fixed here, so go to parallel, select this object first and then this object. Now you can see they will become parallel. This side and this line will become parallel, and this line and this side of the polygon will become parallel to each other. Suppose you want to maintain the side, maintain the rectangularity, you can do auto constraint, enter. Okay, so see, go to parallel, select this and this. So go to parallel, select this and this. So see, they became parallel and this side is also parallel. But now what I am going to do, look at here very carefully. Suppose I want to maintain the polygon shape as well. So go to auto constraint and select this, enter. Now let's try to do parallel constraint. See, the shape is maintained, but it is not a regular polygon. Okay, and they became parallel. But one thing you must notice, that the shape will be maintained, the hexagon is irregular. Okay, suppose you want to maintain the shape of regular hexagon only. Regular hexagon means all the sides of hexagon are equal. Then you have to apply some more constraint. Auto constraint have some limitations as well. Okay, so that's it. Now let's create a rectangle here. See, this is the line and this is the rectangle. Select this. This is the perpendicular geometric constraint. So select this side and this side. See, they became perpendicular to each other and they will always remain perpendicular to each other. See, once I try to change the inclination of the line, accordingly that side, that particular side of the rectangle will also change. I hope you are getting my point. You can practice actually. You can draw rectangle, you can draw hexagon, and you can try to constrain it so that its shape, its size will always remain same only. Okay, suppose I have drawn a hexagon. Number of side is 6. Center of the polygon is this, inscribed in circle. Now you can see this. This is a polygon, or you can say hexagon, and I want the size and shape of the polygon, that is hexagon, must remain like this. So you can do something like, see, we have equal constraint. What equal constraint? Go to equal constraint, select this. Again go to equal constraint, select this and this. So these two will become equal. Again go to equal constraint, select this and this. Again go to equal constraint, select this and this. Again go to equal constraint, select this and this. So all the sides will now be equal. Now I can say that this particular hexagon will always remain equal, will always remain regular. Try to change. See, now it is a regular? No. What is the definition of regular? Regular hexagon means the interior angles must remain equal. All the interior angle of the hexagon must remain equal, and all the sides of the hexagon must remain equal. So it is still not a regular hexagon. See, all the sides are same, but the angles are different. So for that, you can do that. See, this side will become parallel to this side. So go to parallel constraint, select this side and this side. Okay. Now, again go to parallel constraint, select this side and this side. Oh, conflict is there. Select this side and this side. Again, conflict is there. So let us try to change it. See, now you can see that The angle is not fixed. So what we can do, suppose if I try to do parallel constraint between this side and this side, what is showing here, see, the constraint cannot be applied. It conflicts the existing constraint or would over constrain the geometry. That means if I try to constrain this parallel to this side and this side, means if I try to do this parallel, so it will be over constraint. Over constraint means even if we don't do the parallel constraint between these two side, then this will be fine. Now only thing which is remaining is the angle between them, the angle between them, that we can give from here. Angular constraint, angular dimensional constraint. Can you see that? Angular dimensional constraint. So go to angular dimensional constraint, select this and this. So it will be 120. Okay, press enter. Exactly. Again, go to angular dimensional constraint, select this and this. This will be 120. Enter. Okay. So again, go to angular dimensional constraint, give this and this. Now again, it is showing applying a dimensional constraint would over constraint. Whenever you will see this result, now, whenever you will see this thing, directly cancel it because it will try to over constrain. Now try to move it. Now you can see that it has become a regular hexagon. However, however, the size of the hexagon can be changed because the sides are not yet fixed. The sides length are not yet fixed. But this will always remain regular hexagon. Try to change it, try to change it, try to push this. See what it is happening. It will always remain regular only, but means the shape will maintain. The shape will be maintained, but the size won't. So for maintaining the side, what you can do is go to linear, go to linear. Can you see that? Go to linear, go to linear dimensional constraint and select this side, uh, polyline, and select this side. Wait a second. Rather go to aligned. Aligned. This is the first point. This one polyline, and this is the second. Again polyline. So suppose I want the side length. Okay, I don't want the side length to be 65. I want it to be 80. So write 80 here. Now you can see that. Now you can rotate this. Okay, you can rotate this only, and you cannot change the size also. So shape and size will be maintained, but I want this hexagon to remain fixed. So go to this fixed constraint, fixed geometric constraint here, right here, and go to object and select this object. Now you cannot move. Now still it is moving. Still it is moving. Now I have still it is moving in the horizontal direction. Can you see that? Yes. Do undo. So do one thing. Go to fix and select this point. Now see, try to move it. Still it is moving. 1 second. Go to this, select this point. Inconsistent, something inconsistent is showing. Wait a second. Maybe we can do this point. Over constraint is showing. Polyline. Now let us try to move it. So it is moving in the horizontal direction, but in the vertical direction it will not move. Okay, so I think only up to this part we can constrain it. Okay, let us explore some more things, okay, of constraints, because these things are all remaining, and lots of what can I say, lots of options in dimensional constraint is also remaining. So let us explore that, then we will come to this part again. Okay, so up to this part I have made the constraint. You can see that. Okay, means it will always remain regular hexagon, all the sides will be equal, and the length of the side of this hexagon will always remain this 80. I hope you are getting my point. Okay, now to constrain this, we can do one thing. See, create a line. See, I have create a line. Now make this line go to vertical constraint. Go to vertical and select this. So this line will become vertical, and this line will always be vertical. And also go to fix and select this. So you can see this line will remain vertical, but this point will always remain like this. Now go to linear dimension. Let us try to do that. Go to linear dimension, select this point and select this point, actually polyline, and set the distance. Okay, set the distance as 120. Enter. Now I think this is constraint. Now you cannot move this. So with the help of this line, I made this I made this regular hexagon a completely constrained, fully constrained. Fully constrained means you cannot change the side length, you cannot change the interior angles between them, and you cannot change the shape, and you cannot change the position also. So that's the fully constrained. Fully constrained means size should be logged. You cannot change the size, you cannot change the shape, and also you cannot change the position. That's the definition of fully constrained. So I took help of this particular line to fully constrain this particular regular hexagon. What I did, I made this line a vertical line, and then I made a fixed point here with the help of this fixed constraint. Now we have next constraint. Let us draw one more line. Let us draw a rectangle. Oh, I'm sorry. Go to rectangle. Okay. Now, can you see that we have horizontal constraint? Go to horizontal constraint and select this. So that side will become horizontal. That's it. If you go to horizontal constraint and select this line will become horizontal. Okay. It's as simple as that. See, horizontal, like that. Okay. See, this is vertical. So vertical constraint and horizontal constraint, like that. Suppose now let me delete this. So this is a rectangle. Let us try to constrain this rectangle. So this will be always vertical and this will be always horizontal, this side. Now this side and this side must always be parallel. So select this and this. And this side and this side will always be parallel. So go to parallel constraint, select this and this. Okay, now you can see that you can see, we means you cannot change the shape. The shape will always remain rectangle, but the size is getting changed. Size is getting changed means length and breadth is getting changed. So you can go to linear dimensional constraint. You can directly select this end point and this end point. Okay, go to linear dimension, go to linear dimension. Okay, linear dimension constraint, select this endpoint and select this endpoint and place it. Okay, suppose you want to change it, again left click onto that. Suppose I want to make it 200, enter. Okay, now go to linear, again select this endpoint. Once you select this endpoint, it will ask which dimension, which you want to select, polyline or rotated dimension. Obviously I want to select polyline. Polyline, obviously rectangle is a polyline, and also this endpoint. Okay, now place it. Once you place it, you will see that it will look like this. So left click here and delete that and make it as 120 and press enter. So this is done. Now you can see, now we have to fix the position. Now how to fix the position? You can select this and you can go to fix geometric constraint and select this point. Now try to move it. You won't be able to move this particular rectangle. So this rectangle is fully constrained because its shape will remain a rectangle. Its size will remain as it is, that is 200 cross 120, and its position will also remain fixed. So that's the fully constrained rectangle. After that, we have tangent. We have tangent, right? Let's create circle. Obviously, if we want to do the tangency, then circle plays a very important role. So go to tangent, geometric constraint tangent, select this and this. See how that circle and line became tangent to each other. Okay, go to tangent, geometric constraint tangency wala, and select this and this. Obviously the second object will move. Let's select this as let me select this circle first, then this line. See, so they became tangential constraint. It's very simple. Okay, now let me show you a magic. Let us draw two circles. Let's try to apply this equal constraint. Equal constraint you means two lines segment can be equal length, okay, or two circle can be equal. See how, go to equal, select this circle and this circle. Now this circle and this circle will have same radius. Try to change the radius of this circle. The other circle radius will automatically change. You can see that it will automatically change. I hope this is clear. That's the equal. Suppose go to rectangle command, because in the rectangle these two sides must be equal. So go to equal constraint, select this and this. Again go to equal constraint, select this and this. So they will become equal and they will become equal. Okay, so that's the beauty of equal constraint. Now okay, now this circle and this circle must be equal. Okay, yes. I have put equal constraint in this, and this circle and this circle must be equal, and also this circle and this circle must be coincident. Coincident means concentric. And I want to change the position of this circle, so this will be selected first and this, so they will become concentric. I will create another circle somewhere here. Now this circle and this circle must be concentric, and this circle will remain fixed and this will move. So go to concentric, select this first and then this. Okay, and this circle must be equal to this. Oh, sorry. This circle and this circle must be equal. So go to equal constraint. First select this and then this. I hope this is clear. Now, now this three circle must maintain their position. So we can go to fix, select this. Again, go to fix, select this. Again, go to fixed and select the center of the circle. So now you cannot move this circle. See, try to move it, you won't be able to move it. Okay, you can apply move command. Move command, go to move command, M enter, select this, enter, try to move it. You won't be able to move it because all these three are fixed. Now, after this, go to tangent, select this and this. So the circle will enlarge, which I don't want, So what I can do is go to tangent, select this first and this. Again, select this first and this. Okay, like that. Suppose you want to maintain the radius. So you can go to this radius constraint. Go to radius, select this. Suppose the radius is 40. Okay, and go to this radius constraint here and select this. Suppose the radius is 30. Enter. Okay, so if I have set this radius and this radius, so these two will automatically same. Yes, and go to radius, select this. Suppose this radius is 55, equal to 55, equal to 55. Okay, now make the tangency constraints. Select this and this. Again go to tangency constraint, select this and this. Again go to tangency constraint, select this and this. Again go to tangency constraint, select this and this, like that. And you can stretch a bit. And we need one more. Select this and this. Again go to tangency constraint, select this and this. Now we will apply trim command, tr double enter. Select this and this. delete this, select this. So you can see this. Now we can apply a fillet command here. Go to F, enter, go to radius. Let's say fillet radius is 55. Enter. Select this and this. And this extra part can be trimmed. Actually, you can directly trim this rather. Yes, it will look fine only. Here also, go to fillet, F, enter, go to radius. The radius is 55. Select this and this. And you can trim the extra part like this. So you can see this thing. So this is nothing but a mechanical component called lever. Yes. So this is done. This is the 2D object of it. Now you can do auto constraint. Go to auto constraint and select all and enter. So if we do that, what will happen? At least some more constraint will be added to this. At least the figure will not be disturbed now. Yes. Means the chances of disturbing the figure will be less now if I do the auto constraint. So that's the beauty of the geometric constraint which I was telling till now. Okay, I have given some, like I have given radius and all those stuffs. You can give align dimensions to this. If you want to give, you can give that from here. See, enter. Suppose you want to give from here align dimension from here to here. Enter like this. If you want to give it here, you can give it from here as well. Enter. Go to again align dimension, select this and this. Okay, enter. So some again problem is there, so don't need to give this. So that is done. So I have explained this thing till now. Now only these two options are remaining. This is smooth and symmetry. But before that, I want to explain something. I want to explain something. Let us see that. Uh, let's keep it here. Let us draw here circle. Go to circle. Let us finish up this particular dimensional constraint. Go to diameter and select this. You will see the diameter. Okay, so that's very simple. Go to circle, go to diameter. So like this. Okay, now if you see here we have angular dimensional constraint. So go to angular dimensional constraint, select this and this. So their angle will be fixed now. 127, okay, press enter. Again, it is showing over constraint is there. So that's why we cannot dimension it because I have done auto constraint. So that's why some constraint might have added. Due to that, it is not happening. Okay, now angular dimension you can give between any two lines. Suppose these are two lines. Go to this point, angular dimension, select this and this. Enter. So angular dimension is done. So it's very simple. Now you cannot change the angle between these two lines. The angle between the two lines will always remain 58. Okay, yes, exactly. Now let us see some more thing. Aligned, I have explained. Now let's go to horizontal. Go to rectangle. Let's go to this horizontal dimensional constraint. So select this and this. So what it is showing? See, if I go to aligned, if I select this point and this point, so it will show the actual dimension, that is the aligned dimension. Press enter. But if I go to horizontal, if I select this point, polyline, and oh, let us take this, select this point and this point. As of now, I am inside the horizontal, okay, horizontal dimensional constraint. So select this point and this point. So the x distance between that 2 points, that is the horizontal distance between those 2 points, will show. It's very simple. If you go to vertical, select this point. Obviously, this selection cycling will show. Select the polyline. Again, select this point and select polyline. Now you will see that the vertical distance will show up, and that will be the vertical constraint. I hope this is clear. Okay, now go to rectangle. You can convert any normal dimension into a constraint dimension. Let us use dim command. Dim command. Okay, again use dim command. See here. Okay, now you can convert these dimensions. You can convert these dimensions. Select this. Can you see this option? Convert. Select this. Click on the dimensions which you want to convert. Click on this. Click on this and press enter. So see, those two dimensions will be converted. Okay, go to dimension constraint, select this. Some problem is happening, it is not getting converted. Okay, let it be. Now suppose if I give, if I go to dim command, go to angular, select this and this, so 90 degree. Now go to convert and select this, enter. So it is not getting converted, some problem is happening. Let me explain why. See, let us see what was the problem that was happening. Suppose if I create a rectangle, okay, now let's go to dim command again, select this and this. Now I want to convert it, so go to convert and select this, so that will be converted. Now if I go to dim command again, select this point and this point. Now if I try to give convert this and enter, now you can see in one particular entity you can convert only one dimension, like this. Suppose you want to give constraint command, then you have to, means constraint dimension, you have to give it from here. Okay, so 1 second, polyline, yes, like this, enter. So you have to do like this. Okay, so that's nothing to worry, that's not a very big deal. Okay, so we can give from here only, this constraint dimension, means dimensional constraint. Now after doing this, we have a very important tool which is very important, that is parameters manager. Once you go to parameters manager, you can see that we have lots of options and you will get confused. So what I am going to do, I will delete some of the objects, delete this. Okay, now go to parameters manager. Now some less things are there. Now suppose we have some values and we have some name. See, radius 2. Where is the radius 2? Can you see that? Yes, here is the radius 2 is there. And where is the radius 3? Here is the radius 3 is there. Suppose I want to give some relation between radius 2 and radius 3. So suppose this is 30, but radius 3 I want something like this. Suppose I want 2 multiplied by radius 2, means whatever be the radius 2 value, radius 3 is nothing but 2 multiplied by radius 2. Press enter. You will see that radius 3 is equal to 2 into radius 2, means if radius 3 if if radius 2 is 40, if radius 2 is 40, you can see that if radius 2 is 40, if radius 2 is 50, then the size will increase. The radius 3 size will also increase. Make it 30 only, like this. Okay, so that's the beauty. Now we have different dimensions, d1, okay, d3 and d2. So suppose I want to make some relation between them. Okay, suppose d1 is, let us make it as 120. One second. Let us make it as 140. That will be fine. Invalid value it is showing. So we have to keep it 141 only. One second. Okay, so we cannot change it actually. It must be 141.5927. Yes, you cannot change it because of some constraint and restriction. Okay, so I was trying to give the relation between them. You can give relation also. Okay, let us see. One second. You can create a new parameter from here as well. Okay, that is of no use as of now. Yes. So after this, let me close it. I want to show something. Let me delete this now. Okay, go to rectangle. I have created this rectangle. Okay, now suppose if I give linear dimension, this and this, enter. Let's give linear dimension here as well. Polyline and select this. So that is the linear dimension. Okay, now suppose go to parameters manager. We can change it from here as well. Suppose if I try to give it 200, it will change into 200. Means I can change the dimension value from the parameters manager as well. That's what I wanted to show you. Suppose D2 I want D1 divided by 2. Enter. See how the parameters changed. Okay, and I forgot to give equal constraint. So go to equal constraint, select this and this. Again go to equal constraint, select this and this. And go to parameters manager. You will see only two parameters are there because only two dimensional value has been shown. So that's what I wanted to show here. I hope this is clear. Now, after this, after this parameters manager, we have some more options to see. Let us see one by one. Can you see till now this annotational constraint mode was activated? Let us activate the dynamic constraint mode now. Okay, now dimensional constraint mode is activated. Now let us create a rectangle here. let us create a rectangle. Okay, as of now, means dynamic constraint mode is activated now. Go to linear, select this and this, press enter. Go to linear, select this and this, press enter. Can you see that? Can you see one thing? What is the difference between this one? This one was made using annotate dimensional annotational constant mode. Now see, this was made when dynamic constraint mode was activated. Now I will activate this annotational constraint mode. Now I will draw one more rectangle. Okay, go to linear, select this and this, enter. Again go to linear, select this and this, press enter. So this dimensional constraint is made when annotational constraint mode was on. What is the difference between them? Do we have any difference? Yes, it has some difference. So this was made using annotational constraint mode and this was using dynamic constraint mode. So go to Control P, that is plot. To see the result, you have to go to plot. From here, select TWG to PDA. What to plot? Go to window. I want to plot this and center the plot. We can change the size like this and you can see the preview. See the preview. This dimension was given using annotational constraint mode on, and this rectangle dimension was given using dynamic constraint mode. So see, the dimension will not show. The dimension will not show if you have dimensioned it, if you have given the dimensional constraint using dynamic mode on. So this was done using annotational mode on, and this constraint, dimensional constraint, was given to this rectangle by dynamic mode on. So that's it. So this is dynamic mode, this is the annotational mode. So only the annotational mode dimension will show in the plot area. I hope this is clear. You can delete the constraint from here as well. Select this and select this, enter. That constraint will be deleted. Whatever constraint you want to delete, you can delete anything. Okay, go to delete constraint, select this and delete it like that. You can show or hide, you can hide all, you can show all like that. Okay, yes. Now, even so, this is for dimensional. Suppose some constraint is there. Okay, suppose I want to make it coincident, this and this. So you can hide as well. This one, show all, hide all, show all, hide all. Geometric constraint. So to show all or hide all the geometric constraint, you have to do this. Suppose you want to show any particular constraint and you want to hide any particular constraint. So you have to use this option. Okay, suppose go to this and show all. Now you can see this. You can do this from here as well. Right click onto this and hide it. So you can hide it as well, or you can delete it as well, whatever you want to do. Now after this, so this is very simple. This is also very simple. This is used to hide or show the dimensional constraint. This is used to hide or show the geometric constraint. Now we have next option, this one, smooth. Create a spline. Create a spline. Create a spline. I have created two splines. Now go to smooth, select this point and select this point. So actually those two spline will be joined using this smooth. That's it. Okay. Now we have symmetry. So let's do that also. Create a rectangle and create a line, suppose. Now go to symmetry, select the first object. This is the first object. And let's say this is the second object. Wait a second. Create a rectangle here. Create one more rectangle here. Go to symmetry, select the first object. Suppose this is the first object. Suppose this is the second object. And symmetry line. We have to select the symmetry line. Suppose this is the symmetry line. So can you see that? This was the first object, this was the second object, and this was the symmetry line. This was the symmetry line. So this, if you change it, this will also change. If you change the position of this line will also change its position with respect to this symmetry line. Let me explain this again. Let us create a rectangle here. Let us create one more rectangle here. Let us create a line here. Let us create a line here. Okay. Yes. Make it vertical. Go to vertical constraint and select it. Now go to symmetry. This is the first object. This is the second object. And this is the symmetry line. So this line, this vertical line, this line will be symmetry. Means this distance and this distance will always be equal. That's the symmetry. I hope you are getting my point. Exactly. So that's it from this parametric ribbon bar.